Okay, in this video we are going to talk about the box and whiskers plot. Another way that people refer to this is just as the box plot. The way that this looks, the reason why it's called a box and whiskers plot is because it looks like a box that has whiskers on the end. Okay, so these are the whiskers, this is the box in the middle. All of these things represent different parts of a set of data. So essentially, this is just like a visual representation, like a histogram or a frequency distribution or a pie chart of a set of data. It's a little bit different though, because it shows a lot more information about your data. It's more of a statistics graph versus those are just a visual representation of your data. Okay, so this it's technically still a visual representation, but it gives us much more information. The very, very end of the first whisker, or the whisker on the left, that is the minimum value. The very, very end of the whisker on the right is the maximum value. So from this graph, you can see the minimum value and the maximum value of your set of data. These three lines are different quartiles of your data. Okay, so the middle one is your second quartile, the first one is your first quartile, and the last one is your third quartile. Okay, so quartiles. If you think quartiles, it's like the word quarter, so it's split into 4 parts. Okay, so your data is split into 4 sections. So your data is split into 4 sections. And you can see the 4 sections are quartile 1 is from the minimum to quartile 1. So this whisker is 1 section of data. Okay, quartile 1 to quartile 2 is the box. That's the second section. So I can just kind of write that. So this is the first section. This is the second section. This is the third section of your data. And this is the 4th section of your data. Notice that they are not all the same size. In most situations, they're not all the same size, and that tells us some information about our set of data. Okay, but I take my, let's say 12 values. Let's say you have 12 values in your stuff, in your set of data. If you divide that by 4, there's going to be 3 values in each section. So there's 3 values here, 3 values here, 3 values here, 3 values here. Okay, if I had 100 sets of data, 25 of my values would be in the first section, 25 would be in the second section, 25 would be here, 25 would be here. Okay, so 25% of your data is in each whisker. Okay, so in the first whisker and in the last whisker, the first section and the 4th section, 25% is in each. So 25% here, 25% here, and then 25% of data values are in each box. So 25, 25, 25, 25 is 100% of your data. Okay, so let's go back to the idea of why are they not the same length. Okay, so all these pieces will not be the same length. Sometimes they are, but more than likely they are not the same length. The reason why is because they are showing the spread of the data. Okay, so if you have a smaller section or smaller piece, that tells us that the spread is not very big. That tells us that the spread is very small. So that means that our numbers are really, really close together. So it might be like the numbers 12, 13, and 14 versus 4, 10, 20. Okay, so a smaller section tells us that our data values are clustered close together. Okay, if it is a larger section, so if it's a larger section, like for example, that's kind of larger. It's not that much bigger, but let's say if it was a really, really big piece, that tells us that the spread of that data is a lot bigger. So that tells us that our numbers are not very close together. They are more spread out. Okay, so data values are more spread out. Okay, so data values are more spread out. I hope that kind of makes sense. So if I was going to put some numbers in here, let's say like this would be like, if the first three numbers were like 0, 2, and 10. And then the next three numbers in my section would be like, I don't know, 11, 13, 17. And this might be like 18, 19, 20. And this would be like 21, 23, 27. I don't know, I just kind of made those up. But I hope that kind of makes sense that like this section is the small section, so those numbers are closest together. But I have the same amount of numbers in each section, or same amount of your data in each section. Okay, so these numbers are the 5 important numbers that you have to make a box and whisker plot. You need the minimum, you need the maximum, you need Q1, Q2, Q3. Okay, and these are your quartiles. That's what those are called. Okay, so this is how we create a box plot. So I'm going to go ahead and instead of writing all this down, I'm going to put up the instructions on how to create a box plot. If you want to write it down, you are more than welcome to write it down, or if you just want to listen and then we will go over it together. So this is how you create a box and whiskers plot. First, you plot all your values on the number line. I'll show you how to do that in a second. You find the median of your data. The median is Q2, and that's where you draw your vertical line for your boxes. From there, you find the median of the first half of data. That's Q1. Find the median of the second half of data. That's Q3. And then from there, you finish drawing your box and your whiskers by using your minimum and maximum. Okay, so pause the video here if you want to write all that down. Okay, so let's do an example together. So if I give you the numbers 3, 5, 7, 7, 8, 9, 10. Okay, so you notice these numbers are already in order, so I don't have to put them in order. If they are not in order, your first step would be to put them in order. From there, I need to put these on a number line. Okay, so on my number line is going to start at 3, and it needs to go all the way up to 10. So 3, 4, 5, 6, 7, 8, 9, 10. Oops. So that is how big my box plot is going to be from 3 to 10. Okay, it's going to be this wide. From there, I need to find my Q2 value. Okay, my Q2 value is the median number. In this set of data, I have 1, 2, 3, 4, 5, 6, 7 values. That means it's an odd set of numbers, so that tells me that my middle number is my median. So you could like go through, you don't want to mark these out because we're still going to find the other values, but you could go through and like put a dot under each one of them to find your middle value. That is your Q2 value. Okay, so this is my Q2 value right here. Okay, that is going to be, if you remember what, that's going to be this middle line right here in the middle. So underneath it, I'm going to make my line in the middle for Q2. Okay, from there, since I had a median, since that 7 in the middle is the median, I am not going to use that number anymore because I already used it for the Q2 value. So now to find my my quartile 1, Q1, I take my first set of numbers and find the median from there. Well, the median of the first set of numbers, 3, 5, and 7, is 5. That is my Q1. Okay, so I'm going to put that on my graph. 5 is Q1. That is this line of your box plot. Okay, so I'm gonna put a line there. You could go ahead and like make your box there if you wanted to. I need to do the same thing on the other side for Q3. So again, I'm not using 7 because I already used the number 7 for my Q2. That's my line. So now, out of my 3 numbers, 9 is the Q3 number. Kind of looks like Christmas on the page. Sorry about that. So 9, this is the Q3 number. So I'm going to put my line there. I can go ahead and make my box from there. Okay, and then from that point, I can go ahead and put my whiskers. So to put your whiskers on there, this is the minimum value of 3. This is the maximum value of 10. And we do include numbers on our box. So 3 is the minimum, Q1 is 5, Q2 is 7, Q3 is 9, my maximum is 10. Okay, so a few things you can see from here. First of all, we can kind of see that my number line is not very symmetric because here, the distance from Q1 to Q2 is 5, 6, 7. It's just 2 numbers there. Same thing here, distance from Q2 to Q3 is 7, 8, 9. It's just 2 numbers. So technically these boxes should be the exact same size. Mine didn't really turn out the same size, but they're close. They're pretty close. You can kind of see here though, this whisker is longer than this whisker. And the reason why is because the numbers 3, 4 are here. The number 9, 10 is here. Okay, so this is shorter than this whisker is. Okay, so I hope you can kind of see that's how you do a box and whisker plot. It comes out a little bit different when we do not have, in this case, we had an odd set of data, so it's easy to find this median, easy to find this median, easy to find this median. Sometimes they don't work out quite so nicely, so let's go over some like that. So let's do a problem. This one has 8 data values instead of numbers. Again, real fast, this is my answer. The reason why I had to do that number line was to be able to draw it a little more accurately than just throwing it on there, okay? So for number 2, our set of numbers is 5, 6, 6, 8, 9, 10, 11, 12. For this one, first thing we do is put on our number line. We need numbers from 5 to 12. So let me start off at 5. So 5, I'm trying to make it a little more even this time. 6, 7, 8, 9, 10, 11, 12. And I always make it too long. I don't know why I do that. So that's how big my box plot's going to be this time. To find the Q2 value, the second quartile value, I need to find the median. So in this case, I have 8 values. So when I break it down, I end up with 2 values in the middle here, 8 and 9. So Q2 is 8 plus 9 divided by 2, which is 17 divided by 2, or you probably could have seen it was going to be 8.5 because that's the number in between 8 and 9. So at 8.5, that's my Q2 value. So that's where my vertical line for my box plot is going to be, in the middle. Okay, so the difference with this one and the last one, when we use 7 as the Q2 value, we did not use that number anymore, and it split my data into these 3 and these 3. In this case, I used 8 and 9 to get my Q2 value, but I didn't actually use the number 8 or the number 9. So when I split it up now, I'm going to use, I'm not going to X those out. Like, I'm going to use those in my 2 pieces. So 8 is still a part of the first set, 9 is a part of the second set to find the Q1 and the Q3. Okay, so when you actually use that number, you can X it out, and that is not a part of Q1 or Q3. When you don't actually use that number as your Q2 value, when you have to find the average, those 2 numbers are a part of the 2 sets of your data now. So now finding the Q1 value would be finding the median of this set. Well, the median of this set would be right here. 6 plus 6 divided by 2 is 6. Okay, so my Q1 value is 6, and that is this line. My Q3 value is 10 plus 11 divided by 2, which is 10.5. So that's my Q3 value is 10.5. So that's going to be about right here. And you can make your box here. And then your whiskers are the minimum and the maximum. So let's put my numbers on here. My minimum is 5, 6 is my Q1, and 8.5 is my Q2, 10.5 is my Q3, and 12 is my maximum. Okay, so I hope that is helpful. Let's go ahead and do one that has a few more numbers on it. Okay, so number 3, I'm still gonna go ahead and give it to you in order. 2, 5, 5, 7, 15, 16, 16, 16, 18, 21, 24, 25, and then 4 30s. 30, 30, 30, 30. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16 values here. So there's an even number of values. So that means I don't have one specific center. For the Q2, I actually have to find it when I go to put these on a number line. So 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not actually writing every number here. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I didn't make it too long this time. Okay, so to find Q2, I'm finding the median of the set of data. So if there's 16 values, the median is going to be in between 8 and 9, right? Or you could go one from the end each time. This is how I like to do it because it's kind of foolproof if you're careful. So right here is where my median is going to be. It's going to be the average of 16 and 18. If you add 16 plus 18 together and you divide by 2, my Q2 value would be 17. So I'm going to go ahead and put a dot on my graph here. That's Q2. I'm going to put my vertical line down there. I didn't use 16 or 18. My Q2 value is the number in between them. So now this splits my data into 2 different sections. Here's the first section, 2, 5, 5, 7, 15, 16, 16, 16. The median of that would be 1, 2, 3, 4, 5, 6, 7, 8 values there. So the median would be the number in between 7 and 15. So if you add it together, this is my Q1 value. 7 plus 15 is 22. Yeah, just making sure. 22 divided by 2 is 11. So my Q1 value is 11. I'm going to go right underneath that. Q1 is 11. Q2 was 17. Same thing on the other side of my median. There are 8 values there. 1, 2, 3, 1, 2, 3. So in between 25 and 30, that is my Q3 value. So Q3 is 25 plus 30 divided by 2, which is 55 divided by 2, which is 27.5. Okay, so Q3 is 27.5. It's right there. So this is my box right here. My whiskers are 30 is the biggest and 2 is the smallest. Oh, I didn't know this one either, 27.5. Okay, so this tells me a few different things. So 50% of my data is in the box, right? Because it's 2 quartiles. The other 50% of my data is in the whiskers, 25% here, 25% here. This whisker is so much shorter than this whisker. Why is it so much shorter? Well, the reason why it's so much shorter is if you look at the the last 4 numbers of your data, they're all 30. Okay, so that's why it's so short right there. If you look at the first 4 numbers of your data, it's 2, 5, 5, 7. So like there's a distance of 5 from 2 to 7, just 5 right there, and there's no distance here. Okay, and then it jumps up to 15. So I hope that helps you see the reason why this is longer is because these numbers are more spread out versus these numbers that aren't spread out hardly at all. Okay, so let's take a second and let's look at, I have one, actually, let's go ahead and look at stem and leaf plots at this point. Okay, we will come back to box plots in a minute. I want to talk about a stem and leaf plot. Okay, a stem and leaf plot is another way to represent data. And we use this, or the way that this is done is that we split the data by the digits. Okay, so what that means is, for example, if I had, let me just show you what a stem and leaf plot looks like, and then you can kind of see. So there's going to be a stem on this side and a leaf on the right side. So stem's on the left side, leaf's on the right side. And the idea is the stem is the tens place, hundreds place, thousands place, depending on how big it gets. The leaf is always a single digit, which would be just the ones place. So for example, if I had 0 tens, we're talking about all the numbers in my data that have 0 tens. Let's say we just had the number 2 and the number 7. You don't separate them with commas. It just means I have 2 different numbers here that have a 0 for a 10. What if I had 1 10 and let's say I had the number 10, 15, and 16? This would be the 10 and I would have 0 ones for that number. For 15, I have 1 10 and 5 ones for that number. For 16, I have 1 10 and 6 ones for that number. And let's say the numbers with 2 tens would be, let's say it was 21 and 22. Okay, so 2 tens, 1 1, 2 tens, 2 ones. And then the last one would be 3, and that would be the numbers that are 30s. Let's say we had 30, 31, 31. So 30 would have a 0, 31 would have a 1, 31 would have a 1. Okay, so the values here, like the set of data here, is the number 2, the number 7. These are all numbers that have a 1 in the tens place, so this would be 10, 15, 16. All these numbers have a 2 in the tens place, so this would be 21, 22. All these numbers have a 3 in the tens place, so 30, 31, 31. Okay, so that's pretty much it. One nice thing about stem and leaf plots is that it automatically puts the numbers in order for you. So if you were finding the median from here, it wouldn't be too bad. The first number would be 2, the last number would be 1, the next number would be 7, then 1, and then 10. I'm sorry, this was 31, 31, and then 10, 30, 15, 22, 16, 21. So 16 and 21 are the 2 middle numbers, and you could average them together. Okay, so, and it also helps you see like where the majority of the numbers are. If you have a ton of numbers in the tens and with a 1 in the tens place and the teens or whatever, you can see there's a lot more of them there versus the top or the bottom, so on and so forth. Okay, so let's go ahead and do a stem and leaf plot for this problem right here for number 3. Okay, so I'm gonna do it like this so I can see the numbers a little bit better. There we go. So the stem and leaf plot for this, my stems I'm going to have, these all have 0 in the tens place. These all have 1s in the tens place. These all have 2, those 3 have 2s in the tens place, and those have a 3 in the tens place. Okay, and then my leaf over here, the ones that have 0 in the tens place, 2, 5, 5, 7. So it'd be 2, 2, 5, 5, 7. The one that has a 1 in the tens place would be 15, 16, 16, 16, 18. So 5, 6, 6, 6, 8. A 2 in the tens place is 21, 24, 25. So 1, 4, 5. And then 4 30s, so 0, 0, 0, 0. Okay, so I hope that you can see another thing that's easy to find is the mode. What is the mode in this problem? 30, because there's 4 zeros here and there's not 4 of the same number in a row here. Okay. Okay, so I hope that helps you with stem and leaf plot. That is the general idea of it. Let's go ahead and talk a little bit more about box plots now. We're going to talk about, get a little more in depth on them. So with box plots, we already wrote down those, whenever you have a box plot, you have numbers. This number 3, 5, 7, 9, 10. There are 5 important numbers on a box plot. That's called the 5-number summary. So a 5-number summary is the minimum, the maximum, Q1, Q2, and Q3. Okay, again, the reason why those are the most important ones is because it tells us the lowest number, the highest number, and then it also tells us like our numbers, our data split into quarters because we have quartile 1, quartile 2, quartile 3. The reason why we don't have quartile 4 is because that's the maximum. Quartile 0 is the minimum. Essentially, you could think about these as like Q0, Q5, Q4, 1, 2, 3, essentially. Okay, so one thing that is very important is the inner quartile range. Okay, this is also called the IQR. The inner quartile range is the spread of the data inside the boxes. Okay, so the spread of the data inside the boxes is the spread of this data inside right there. So what percentage of your data falls inside the boxes? I hope that at home you said 50% because half of our data is here, the other half is on the outside in the whiskers. Okay, so it is the middle half of our data. Okay, so it's the middle 50% of your data. Okay, these are the numbers that you normally see or what you would expect to get in most cases because it is the middle of your data. Okay, so what you normally see or expect to get. So the way we find the inner quartile range, the way we find the IQR, the way you would find the range here is the highest number in the box minus the lowest number in the box. So it's this number minus this number, which that is Q3 minus Q1. So inner quartile range is Q3 minus Q1. Okay, so the reason why we need to know that is because that's what helps us find outliers. We talked we talked in the last video that outliers are very large or very small numbers that skew your data. Well, the question is how much is vary? Okay, it depends on the other set of numbers in your data. If all the numbers are clustered really, really close together, and then I have this one way over here, That's obviously an outlier. What about if they were really spread out and then I had one over here? Is that an outlier? So that's what we use the interquartile range to tell us. And the outlier, and something is an outlier if there's two different options here. We can have a small outlier and a large outlier. I might be saying that backwards. So like on, we can have a number that's really, really small over here that's an outlier, or a number really, really big over here that's an outlier. So there's technically two formulas to find outliers, because you could have a really, really small outlier or a really, really big outlier. Here's the formula for the small outlier. The small outlier is, it's a number that is less than or equal to this number. Okay, so if your number is, it's Q1 minus 1.5 times your interquartile range, if you have a number smaller than that. And we're going to do some examples in just a second. Okay, so if you had a number smaller than Q1 minus 1.5 times your interquartile range, or your large outlier would be a number bigger than Q3 plus 1.5 times your interquartile range. Okay, so let me give you, let's do two problems and let's find the outliers for those two problems. Okay, so I'm gonna call this number one. I don't know what we're on anymore at this point. Okay, so what if I told you just 7 numbers? 8, 18, 13, 14, 12, 29, 32, 15, 11, 16, and 12. Okay, so we want to do all the things. We want to find the box and whisker plots. We want to tell if there are any outliers here. So to do that, the first thing I have to do is put these numbers in order. So when I put these numbers in order, the smallest number is 8. And then 11 is our next smallest number. And then 12, another 12, 13, 14, 15, 16, there's not a 17, 18, 29, 32. I think I got them all. It's always good to count and double check. 1, 2, 3, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here we have them in order. Let's go ahead and do our box plot. To do our box plot, we have to find the median to start off with. So there are 11 values, so I'm going to have a number in the middle that is going to be my median. So let's see. So 14 is my median number, my Q2. Okay, I guess I need to go ahead and do my number line here. So starting off with 8 over here. I'm going to go by 5s again. So 8, 9, 10. I'm just labeling by 5s. I'm only labeling every 5th one. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 26, 27, 28, 29, 30, 31, 32. Okay, so Q2 is going to be at 14. So I'm going to draw a vertical line. So now I use that number, I can exit out, and my first set of data is 8, 11, 12, 12, 13 to find the median, which is Q1. In this case, it is 12 is Q1. So I'm going to come over here on my number line and find 12. This was Q2, this is Q1. Q2 is 14, Q1 is 12. So now to find Q3, I take my second half of data, 15, 16, 18, 29, 32. The middle number is 18. So that is Q2. So 18, 16, 17, 18 would be about right here. I said Q2, sorry, it is Q3. Q2 is your middle. Q3 is 18. So now I have my box in the middle. My minimum value, sorry, is 8. My maximum value is 32. Okay, so you can see the middle of my data is the numbers that I expect to have here is the numbers 12 through 18. You can see that most of your data seems like it's in between 12 and 18. I have a few numbers on the outside, but a lot of my numbers are here on the inside of the data. Okay, it seems like this whisker is way longer than this whisker, so that means that we might have outliers over here. Let's determine what kind of outliers we have. So I have to find the number that is like the tipping point for the outliers, the number that makes it, there's too small for numbers over there. I'm sorry, if there's a number less than a certain number, then it's an outlier, or numbers greater than a certain number is an outlier. So there's two different things here. First thing I need to find before I find any outliers is my inner quartile range. Inner quartile range is Q3 minus Q1. In this case, it is 18 minus 12, which is 6. So that's my IQR is 6. So I have an outlier if in my set of data I have numbers smaller than the formula of Q1 minus 1.5 times your IQR. In this case, Q1 is 12 minus 1.5 times my IQR of 6. Well, 1.5 times 6, what's 1.5 of 6? You type in your calculator, you get 9. So 12 minus 9 is 3. Do I have any numbers that are smaller than 3? Look at your list. Do I have a number smaller than 3? No, because 8 is my smallest number. So I don't have any small outliers here. Okay, so we got to find the other side. We got to find the numbers that are bigger than Q3 plus 1.5 times the IQR. Q3 is 18. 18 plus 1.5 times 6 would be 18 plus 9, which is 27. Do I have any numbers that are bigger than 27? Yes, I do. I have 29 and 32. Okay, these are outliers. So your answer to that question is yes, I have outliers of 29 and 32 are outliers. The way we show outliers on our box and whisker plot is by putting an asterisk where they are at. I have an outlier of 32. I also have one of 29. Okay. So real fast, we had to have a number bigger than 27. Let's pretend like the biggest number here was 27. If the biggest number was 27, I would not have an outlier because 27 actually isn't an outlier. It's a number bigger than 27. 27.1 is an outlier, but 27 is not. If I had the number 2 here, I would have an outlier over there because it's smaller than 3. If I had the number 3, I would not have an outlier. Okay, so I hope that explains outliers. What you are going to have for your homework this week, there's going to be a few problems, and I'm going to say, find the mean, median, mode, range, make a stem and leaf plot, make a box and whisker plot, tell me the inner quartile range, are there outliers for that? You're going to do all of this information for, I think you're probably going to have, I haven't made it yet, but I'm about to go make it. You'll have 4 or 5 different problems that you need to do all this for. My encouragement for you is to be very, very careful when you're doing this. Make sure you write the problem down. You're going to do this on your own sheet of paper. Make sure you write the problem down correctly. Make sure that you don't miss a number when you're putting it back in order, okay? Because that's the most frustrating thing, is doing that part wrong and then all of it's wrong just because you're using the wrong numbers. Okay, so make sure you're very, very careful when you're doing your homework, and let me know if you have any questions about it.